The speaker from our coordinator, Dr. Y. Ravi Kumar, is an associate professor of National Institute of Technology Warangal and coordinator for this workshop. He has been working with 3D printing more than 15 years and remember when it was called rapid prototyping. He has published more than 40 research papers in the reputed journals as well as conference papers. He is instrumental in setting up prototyping laboratory at NIT Warangal. He started MTech program in additive manufacturing in collaboration with Central Manufacturing Institute of Technology, Bengaluru, first time of its kind in India in 2014. He also received Young Engineer of the Year in 2009 from Government of Andhra Pradesh and the Institute of Engineers from the India. And his research interest includes 3D printing, additive manufacturing, BioCAD and bioprinting and the other additive manufacturing technologies. Thank you, Ravi Kumar sir. You can go ahead.
Thank you. Thank you, Dr. Manjay garu. So let me share my screen if I could do it here. Hello.
You can start as it's visible. It's visible.
Can you see my?
Yes, sir. Yes, sir.
Okay, thank you. Thank you. So, good afternoon, friends. So this talk is basically the introduction part of the 3D printing. So what I have planned during this talk, why 3D printing and conventional versus additive manufacturing. Of course, the previous speaker has thrown a good amount of light in conventional versus additive manufacturing. So I want to as crisp as in that content. And what is 3D printing? 3D printing design. Of course, design is the main thing. Like design for additive manufacturing is going to be the key in 3D printing. So I'm going to cover a glimpse of design for 3D printing and 3D printing processes. Anyway, we are going to have a separate session, just a glimpse of 3D printing processes, and of course applications of 3D printing in general and in specific to COVID-19, and finally the future direction of 3D printing. This is what I planned for this session. So then why 3D printing? So 3D printing is definitely a key element in Industry 4.0. So just as a recap, the first industrial revolution, the way back in 1780s to 1860s. So that was the first industrial revolution. That is basically a mechanization is the first industrial revolution where the human muscle power has replaced with steam or a water energy. So that was the industry 1.0. And you have a second industrial revolution. So where you have an assembly lines and the steam and water energy is replaced with electrical power. So that is industry 2.0 during 1870s to 1960. And coming to the third industrial revolution, so where PC, invention of PC is the biggest revolution in industry 3.0, information technology, computing, and of course, automation is the major, the key element in industry 3.0. And now we are living in the fourth industrial revolution called industry 4.0. So if you see the other elements in the industry 4.0, so you have a cyber security system, and you have a big data analysis, and you have augmented reality, and you have Internet of Things called IoT, and you have simulations, and you have system integration. Of course, the computing is now is a cloud-based computing and autonomous systems. So then what about manufacturing in the scenario of industry 4.0? So definitely it is going to be the additive in nature. So a lot of studies are saying that, so it is going to be the key as far as manufacturing is getting shaped definitely from a subtractive into an additive. So that is what the focus is on additive manufacturing and under the industry 4.0 scenario. So then let me give a brief kind of classification. As we know that the lot of difficulties in subtractive, especially when the complexity is more. So if it is simple component like this, you doesn't find much of the difference within additive and subtractive. And more or less, the concern in a subtractive is the scrap, and the concern in the subtractive is a tool, and the concern in the subtractive is a jig or a fixer. But if you increase the complexity of this simple step to a simple component looks like this, a cup, if you want to machine, so then you have to consider several constraints into picture. So it is not that much easy to machine this kind of a component until unless you have some kind of plans or like a tools or a jigs or fixers or a number of axes that a CNC machine is having, what kind of a tool compensation radius. So a lot of things we need to search, and we need to plan, we need to develop, and it will take a long way to do. But what a 3D printing or what a additive manufacturing is going to offer, so it is simplifying your life. So no tool, no jig, no fixer, nothing. So it is adding the material as for the demand. So that is the biggest advantage. Of course, we can put it the other manufacturing or a fabrication process as a formative, as we know that we need to make a die in case of a formative of the shape which you are anticipated. But here the biggest concern is how to make a die, how to design a die, how to fabricate a die. And again, you have to look for the subtractive manufacturing processes. And then if the complexity is more, and then that is what where your additive is playing a vital role under these circumstances. And of course, the earlier speaker has touched about this, the cost comparison versus additive and the conventional manufacturing process. Yes. So my central point here is, so complexity. Say if you are having a component like this, it's very simple. So if it is a CNC machine or it is a die tool making industry, so they can make very easily. But my design got changed. My design as now as organically designed. So it is inspired from the nature. Why? Because which we can see, it is not a conventional cylinder or a conventional circle or a conventional elliptical shape. Why? Because it has derived from the nature, or it is organically designed. So then what about the conventional manufacturing process, where it will go if this is the kind of design? So that's what where we need to focus, or where the beauty of the additive manufacturing or the beauty of the 3D printing will come into picture, as this kind of a designs will be the kind of breaking point or the beauty of the 3D printing. So then if you see this plot between the complexity and the quantity, of course this is the extension of the previous slide. Say if your product complexity is very high and you are looking relatively a less quantity, and definitely 3D printing fabrication technique is the best choice for you. But if your design complexity is medium and looking for the medium quantity, and definitely CNC is the best option to choose. And your complexity is very low and the quantity is very high, definitely the investment costing is the right choice for your application. And your complexity is medium, but though your quantity is high, better go with the injection molding. So this is what where you can take some decision, so in which process you want to adapt. So then what is 3D printing? Of course, nowadays it is not a new word to anybody. Why? Because it's simply the extension of 2D printing. So just we are living in a third generation of printing, we can put it in that way. Why? Because the journey has started with the prototyping called rapid prototyping. Now slowly it has attracted the manufacturers attention. That's what we are talking about, additive manufacturing or 3D printing. It is extension of the two-dimensional printing. So you name any, but all these are synonyms. So the kind of developments has happened from the application of prototyping to the manufacturing, or even for the mass production the people are looking at. So that is the kind of technology. And as we know that the technology, the kind of input for this is a digital model. So either you derive through CAD modeling package, or either you derive from the medical image processing softwares, or further with the CT MRI scan data, or even a 3D digitizing systems or a 3D scanning systems. So use any one of these interface and get the CAD model or the digital model, and you are going to fabricate, or you are going to replicate the digital into physical form, and that will be the 3D printing, or that will be the additive manufacturing, or whatever you call it. Maybe the rapid prototyping, but prototyping has exceeded the application maturity of this technology. Now it has elevated to manufacturing or tooling level. So this is a fundamental slide. So various steps that are there in a 3D printing process. So like we have to start with the CAD model, or a digitized data, or so any means. So you have to bring a digital model. So what is your application? So the major the point which we need to think here is, you tell me your application, so then I will tell you the material. Then accordingly we have to have a design for additive manufacturing, or a design for the 3D printing. So it is not a conventional way of mindset. So we need to change the mindset before we get into the 3D printing. So if we are using the same mindset of 3D, the traditional mindset, you cannot exploit the power of 3D printing. So anyway, so your application is to have a cup of coffee. So then go to any CAD modeling software. So nowadays CAD modeling softwares are open source, a cloud based, or a browser based. So you have a lot of developments. We do not have a big nowadays a RAM or a big setup. So even a browser based software is also available, which you are going to practice in some of the lab sessions. But anyway, nowadays getting a digital model is as easy as that. So then you start with the CAD model, and you convert that CAD model into STL file. So STL file, as we know that it is a tesslated language. So, and incidentally, it has invented by 3D systems, or in turn the Czech Hull or the Charles Hull, who invented the first SLA system, and with the bright uranium project, under that the STL has invented. So you have to, but still, fortunately or unfortunately, still we are using STL as a de facto standard. So then we need to convert your CAD model into STL file. And once you're done, these things will be done in any CAD modeling software, or any reverse engineering software, or any medical imaging processing software. So it depends on where your the kind of data you got it. So then the source of data, it depends. So you convert as STL file. So your job is almost done once you convert as STL file. So then next step is, we need to transfer that STL file into a software which is interfaced with a machine. So in that software, you can fix your parameters. Say, as we know that it's additively manufactured. So what is your layer thickness, and what is the speed of the head, or what is the fill density, or things like that. So depends on what is the, if it's the laser based, what is the laser power. You set all these process parameters in this interfacing software, and you generate a kind of a G code. Normally you do it for the CNC technology. You generate the machine setup and send that data to the machine. So machine is a slave of that instructions, or the contours, or the 2.5D dimensional a contour data, or the layers. So it's going to physically realize in this machine in the fifth step, that is going to build. And of course, next step is we need to remove the part, and in that course, so you need to remove some supports. We'll see what are the supports, and we need to use a different tools or different methods to do a post processing of these parts to enhance. So directly you cannot compete the quality which you are going to get in a traditional manufacturing, until unless you have to have some post processing methods. So then once you do that post processing, so your application in this case, it doesn't require any much of the post processing. Why? Because you are not looking for what is the surface roughness here. So your application is to sip a coffee, but your application is not, it's not going for any kind of a load it is going to take. or it doesn't require any accuracy levels which you are looking at. But that's what is your application. So then accordingly you design, you choose material, and you choose technology, print it and use it for your application. So this is a typical the workflow of any 3D printing process. So of course, so we will be talking about design. Why you want to talk about the 3D printing is fine. Why design is coming this word in this 3D printing design? Why design is so important here? Why can't it be a conventional design? So is it not? That's what I am telling. So you have to change your mindset once you come to the 3D printing route. Why? Because your traditional mindset, say for example, you take this part. For the traditional mindset, this was the design. Why? Because you have to start with a block of material. So of course your mindset will be every time how to remove the block of material from that, the hole or the surface or the kind of curvature. So no, 3D printing is not in that way. So still if your mindset in this way, so you cannot judge your application or your 3D printing capability. So then what kind of a design, or what kind of a design content, or what kind of design in your mind once you come to the 3D printing route? And of course we need to have a typical design thinking. Of course we have a lot of design methodologies nowadays available with any CAD/CAM systems. Maybe started with the parametric modeling. Now generative design is playing a vital role. Of course the topology optimization, nowadays we can use this word oftenly. Why? Because you have such a power. So modeling is not your goal. The goal is to print. So then which technology is going to make, say for example, this is the topologically optimized. So from this traditional design mindset to the topologically optimized part. So in this course, maybe you are exploiting the topological optimization here, and in that course even you may be deriving the structures from the nature, or from the cell culture, or that's what is called as a bionic design or an organic design. So where your structures are not a conventional structures. So why? Because you are imitating the nature, or you are imitating the biology or a cell culture. So that's what where your 3D printing is having a good edge than traditional manufacturing systems. So of course, as Dilip, my earlier speaker, has rightly put the simulation part of it. So as the 3D expert is one which we have at NIT Warangal, and anyway we are going to have a demo by the 3D systems on this 3D expert software. So basically the idea here is to simulate before you manufacture. Definitely it is not a new thing for a CNC practice. You have been doing for the path verification simulations, for the for is there any tool is retracting, or is there tool is collision with the workpiece. We used to do a lot of simulation in CNC. Similar thing which we can do it for the 3D printing. Of course the material for 3D printing, if it is a polymer, you never care. Why? Because per kg it may be 1000 rupees or hardly 1200 rupees per kg if it is a plastic like a PLA or ABS. But if it is a metal like titanium or Inconel or aluminum, or you have a cobalt chrome or any other materials, so then those are very costly. So definitely we need to check for the build failures or any residual stresses. But anyway, I have a less time to talk here. So maybe you are going to have a lively see on the 3D export demo by the Lokesh. Maybe we can explore practically or on the screen how these can be the kind of supports can be simulated, and kind of residual stresses can be minimized, and how we can compensate all these stuffs. So you have not only 3D expert, even you have other softwares too. So you can do all these simulations. And of course I am going to put you in a wonderful way, like why 3D printing, or the 10 mantra of 3D printing, or rather than, let me put it in that way, like say how it differ from the traditional manufacturing practice. So that is the intention of this slide. So are the 10 mantra of 3D printing. So first mantra, of course, the manufacturing complexity is free. Say for example, if you have a cylinder or if you have a this, you doesn't find much difficulty or much efforts in terms of number of steps or the cost you put up in case of 3D printing, in contrast with a traditional machining or a traditional tool making practice. So the manufacturing complexity you're going to get is a free of cost. And another one is a variety is free. What do you mean by this variety is free? Say I can make different geometries, different dimensions, different forms, but all together in a single go. So otherwise I should have planned for tools for each component, and I should have designed for jigs or fixtures if required. So totally, and if it is a die making industry, we have to design each and every die for each and every component. But 3D printing variety is free. So you are going to build as these kind of different geometries, different dimensions, different forms all together in a single go. So the variety is also free of cost here. So, and no assembly is required. So as my previous speaker has given a wonderful a practical example how we can consolidate the part count. Of course nowadays, but it looks like a Lego tie printed separately, but it's not in that way. So it has printed in a single go. So then you can have this kind of advantage. You know what is advantage of minimizing or making 100 parts into a single part, or no assembly is needed here. So that is the another mantra or the advantage or the beauty. And of course zero lead time. So whenever you talk about the supply chains, say for example, if you want to make the component, or so then we need to, I'm talking about a traditional way, then we need to identify who is going to supply your raw material, the block, and who is going to supply the tools, and who is going to supply the kind of a designs or things like that. So you have a lot of supply chain in and around for a traditional manufacturing. But same thing, if I want to 3D print it, I need only 3D printer, that's it. So I need only 3D printer and a software. So and of course a drawing or a blueprint, but I doesn't require any other stuff which you will be moving here and there with a lot of supply chain in case of a traditional manufacturing practices. And of course in that course the lead time may be zero, or the lead time you can reduce drastically. And unlimited design space, what do you mean by this? So again the previous speaker has touched up this one, like, so again and again the designs are inspired from the nature. So your manufacturing facility should not say that whatever you have designed it is not possible to fabricate, right? So you should not get such kind of a reply from the manufacturer. You know what is the design for manufacturing, right? But here you don't have any limit for the design space. So you can have for unlimited design space here, as well fabrication also. Not you're going to print whatever you imagine. And of course you have a zero skill manufacturing. What do you mean by a zero skill manufacturing? So of course it may be a kind of lot of debates we need to, why? Because so if I have a 3D printer at my home and I have a design which is shared through a online repository, or I had downloaded from some kind of a community, 3D printing community, so I can print it from my bedroom, right? So I don't need to go for a shop floor, or I need to go for a tool maker to design a die. No, absolutely. So it doesn't require any skill manufacturing as contrast with the traditional tool making or a kind of a machining. And of course it's a very compact and portable manufacturing. What do you mean by this? So if you take a conventional CNC machine, so which is of a big size, and finally you're going to make a small component on that, but here it's a quite contrast. So your 3D printers are very compact in nature, so it can be printed sometimes maybe bigger than that size of the printer. So that is what we are going to get another advantage here. And of course less wastage by product. Why? Because you are not removing the material, you are adding the material, literally zero waste. And you have an infinite shades of material. What do you mean by this? So this, otherwise you cannot do it conventionally. So if you take a CNC machine, you can either machine a mild steel bar or a titanium, it's a single material block you will be starting. Or similar way, you have an injection molding die, so you're going to get only the plastic parts. You're not going to get a different material or the multiple material. So definitely 3D printing is opening up an opportunity to print different materials in a single go. So you have a kind of say a structural material and a circuitry, so you can print it in a single go. So that is the infinite shades of material, which otherwise you cannot do it traditionally. And of course the last one, so you have a precise physical replication. What do you mean by this? Say so here it is nothing but the seamless integration of your soft to hard. Means you have a digital data and you have a physical object, and vice versa. You have a physical object and you want to digitize it. So then you can play around it. Means from soft to hard or hard to soft. Of course, there must be a 3D scanning technology also integrated with the 3D printing. So that's what these are the mantras of 3D printing. So which we can talk about. So how it will be differ from a conventional process. And then we'll talk about a bit of 3D printing processes. But anyway, we are not going to explore just a glimpse of 3D printing processes. So of course, any technology, material is the key. So the material which you can print it is, you can start with the polymer, you can print metal, you can print ceramics, you can print composites. And apart from this standard 4 classification of your materials, you have another advantage which otherwise you cannot do it in a traditional manufacturing. You have a functional or electronic or a shape memory, or it can be a biological product or a food, or even it can be a living cells. So which otherwise you cannot do it a traditional way of these a special kind of a materials, or a special kind of maybe otherwise you cannot do it conventionally. So of course the raw material, anyway, we have other sessions also to discuss how to make a powder and how to make a filament, things like that. So either one of these forms, like either it can be a powder, or it can be a filament, or it can be a sheet, or it can be a liquid. Normally these are the forms which you can find. Anyway, we are going to have exhaustive sessions on these 3D printing processes. For the time being, I'm skipping this. So then what are the advantage, or the as I already put some kind of a light about the material and uniqueness, the material choice. So one among is a multi-material objects. Means you can grade the material. Say I have some alloy A and I have an alloy B. So I can vary my composition. Maybe alloy A, I can vary the composition B as well, and I can make an alloy C. It's totally the varying, you have the varying compositions. So then you have such a wonderful opportunity, which otherwise you cannot do it conventionally. And of course you have a metal matrix composites also. It is coming up nowadays. And of course you have a grading of vanadium here, a titanium 6-4 vanadium. So where you have graded the vanadium, so across your length of your component. So you have this opportunity through 3D printing. So anyway, as I said, we have 7 processes in the upcoming lectures. So then you have a process, and then we should not forget post-processing. Post-processing is playing a vital role here. Why? Because so we need to have a kind of what you call. So a post-processing may be playing a vital role, especially if we are working with the metal parts. Not only metal parts, the application. What is the application, your component? So that will sometimes you can wonder. Sometimes it may go 70% of the part cost towards post-processing, of course, but not all the case. Definitely it may go up also. Means as we know that you may make only a near net shape, or you may make only a kind of anisotropic property. So if you see the other shades or the other side of the coin, 3D printing. So in order to fill that gap, so you must have some post-processing techniques. So either it can be, of course, the support material supports also playing a vital role. So that may be tackled a bit of designing, some kind of design for additive manufacturing you can tackle, of course, by using some simulation softwares. And surface finishing is another area where we need to improve purely depends on application. What is your application? And of course, a defect reduction. So sometimes you may go with the hipping process, and sometimes you are going to test non-destructive or destructive. So you have all this post-processing stuff. And apart from this post-processing, even nowadays you are talking about industry 4.0. So then can you integrate the industry 4.0 concept like a smart manufacturing, artificial intelligence, right? So definitely you have a lot of scope. People are working for a research, looking for a research. Definitely 3D printing will open up the doors for a lot of research scope. Say for example, so we need to have some, right now none of the 3D printer printing vendor is going to give a in situ monitoring of your melt pool, or in situ monitoring of your the kind of the melt pool, or even any ceramic printing or a polymer printing. Then you can come out with a kind of developing some kind of a sensors, embedding it, or you can come out with a kind of in situ monitoring. And of course, not only monitoring, you get the feedback, and can we change in situ the process parameters to maintain a quality. So that's, you have a huge scope to work on this. And of course, you have a data analysis, so which is the good part of your industry 4.0. So you can do a lot of data analysis in the course, and you have a lot of scope to work. Why? Because STL is not the solution. Right from the design onwards, you have a lot of errors, or a lot of approximations have been done right from the design, means right from the pre-processing, processing, and post-processing. So can we do a kind of a design analysis, and can you adapt some kind of artificial intelligence in your system? Yes. So you have a lot of scope to work. So not only that, so you can have some process quality control and workflow optimizations, and of course data security, like blockchain. So blockchain is, you have a very good scope to work on this. Why? Because nowadays, in future, you are not going to buy the products. I am sure we are going to buy the designs. So these designs are kept it in a digital, in an open platform, or through shared in a repositories or in a community, and there will be a lot of threat. Why? Because definitely we are going to buy the designs but not the parts. So definitely we need to have a blockchain system. Under this scenario, we need to secure your data, of course. And standards, yes. So you have a lot of scope to work. Why? Because hardly you can find the standards for the additive manufacturing. Professor Krishnanand is going to emphasize on the in the 20th session of this FDP. So standardization, qualification, and certification. So these are the three words which it has to mature. So there will be a lot of, why? Because this is a 30-year-old technology, and as far as metal is concerned, it is only 20-year-old technology. So then we need to have a lot of standards should be developed, and a lot of challenges which we need to do a kind of a standardization or a benchmark. So why? Because each process you have 7 processes, so you have a different physics. So how can we standardize? And the biggest challenge is parts are not standard shape, all are customized, all are bionically designed, all are organically designed. So then how do you standardize, right? That is the biggest challenge facing by ISO or ASTM or ASM or DIN standards. You have a huge scope to work on these kind of areas. Of course, we need to have some collaboration with these guys to come out with a kind of standardizing these 3D printed parts. And of course, you have how do you remove the supports? That is the biggest thing. And then in connection with this 70% cost maybe. So then how to remove the metal to metal support? If it is a polymer, altogether it's a different ball game. But it is a metal. So how to remove your supports? How to finish? You are going to get how to improve the finish, how to improve the what you call the microstructural or metallurgical properties. So that is the thing which we need to focus on. So then let me focus on the application part. So the application I have divided into 2 groups. So one is a general application. I will quickly go through. Why? Because my earlier speaker had made me very easy my life. Why? Because he has talked a lot of industrial case studies. So let me quickly scan the applications. Maybe let us see, it may be interesting to you also. Let's say you have a kind of applications. So applications right from the prototyping, that is the first generation which we are talking about. So you have a replacement parts, and you have a kind of a conceptual models, and you have functional prototypes, end usage parts. That's what where you are looking at. So why? Because the technology got matured. So not the conceptual model, not the prototypes, it's going to be the end usage parts. And of course the tooling, jigs, fixes, visual aids, branding, promotions, molds, castings. So you have a plenty of scope to work 3D printing applications. So then right from the prototyping, aerospace, automobile, medical, military, jewelry, industry, construction, sports, clothing, electronics. So but as we discussed previously, the 10 principles of your 3D printing. So then you have a unique advantage. If you take each and every community or each and every industry, there will be an unique advantage once you come to the 3D printing route. So I don't have much of the time to explain this. So anyway, so you are going to exploit the 3D printing power by using the power of 3D printing through all these applications. So right from the prototyping to the end usage parts. And of course, it is giving a kind of a game-changing solution. So game-changing solution. So as we know that the teeth aligners normally people use a kind of wire or a kind of these kind of wires. It will hurt you. So it may be giving a lot of pain to the patient, right? And hardly it may be looking awkward. But if you have a 3D printing aligner, so hardly you can notice, and you don't have a problem of hurting this wire onto the teeth. So nowadays it is becoming a digital dentistry. No more taking a dentures or no more taking impression from the mouth. So it's now a digital dentistry. Of course, customization, and that too is a mass customization, especially if you talk about your hearing aids. Hearing aids normally it's the standard sizes, but you have an opportunity here. You can customize the hearing aid for your root canal size, right? You let it get it scanned your ear and let it be printed. So and a lot of supply chains also compressed. You did not again and again calling the patient sitting and fitting it. Just once you scan it, so your job is done. So you can print it and you can courier it and let him fit it. So that is exactly to his size, right? So you have a lot of scope to work on the mass customization, especially these kind of applications. Not only need not be a medical, it can be a consumer good like shoes, or it can be anything like you can customize spectacles or whatnot. So you have a huge scope. Like India, you have a huge populated country. So once you come out with kind of a business model, business idea, so you can exploit a lot. Why? Because 3D printing doesn't require huge investment to start your business, right? So but your conventional CNC machine may be costing 10 lakhs or 20 lakhs, but 3D printer may cost 1 lakh. You will get a very good reasonable quality product through ABS or a PLA. So you can invest 1 lakh towards your printing and maybe 50,000 towards your scanning. So hardly you can start with your business maybe 2 lakhs, and you can start using the open source software for designing. Yes, absolutely, you can start your business maybe 2 lakhs. So you can wonderfully start your business and look for a kind of opportunity where you can have a lot of mass customization applications in and around. And of course, implants is another area where it will mimic, and again the advantage of mimicking the bone or mimicking the nature or mimicking the anatomy and customization, and in particular personalization. So that is the biggest advantage once you come to the applications in medicine. So either towards implantation, surgical planning, orthopedic casts, or personalization of the medicines, you have a huge scope to work on this. And of course, aviation is another area where we need to have ever quest to reduce the payload. So that is the crux in any aviation kind of industry which you are looking at. So how to minimize the weight of the aircraft in terms of cabin parts or underhood parts. everywhere. So that's what where the 3D printing will come you in the rescue. So these kind of why GE or why Boeing or why Airbus or why all these people are looking around the metal 3D printing especially. Of course, we need to reduce weight, and not only reducing the weight. So reducing the weight, it will give you the double benefit. One will be the production cost, another will be the mileage. So you can save a lot of fuel once you reduce the weight, the payload of the aircraft. And of course, we have another application where the aerospace, where we can consolidate or we can integrate the parts, like you have a fuel injector here and you have a kind of a thrust chamber, but you can both integrate, and you are going to have a lattice structure which your heat carrying capacity. Basically, your idea is to exchange the heat, and that too you are derived this design from the nature, that is the lattice structure. So wonderfully you can do a kind of the performance improvement than the conventional systems. And of course, the earlier speaker has touched up these heat exchanger parts. So you know the advantage of heat exchangers to print through 3D printing. And of course, jewelry in India, you have a lot of business to work for the jewelry. So we Indians, we are very much fond of gold. So if it is 50,000, we never bother. We are keep on buying the gold, right? So we Indian people and biggest users of the 3D printing in India is the jewelry industry. So you have a lot of scope to know, as you know that the 3D the jewelry industry, they use investment casting. So you can make the wax patterns out of it, and or any sacrificial patterns, and further you can print your jewelry items. So that's what where your jewelry is a very good application. And of course, automobile. Recently I came across several articles saying that people are able to print the entire engine. Of course, maybe Formula One car engine, gearbox. So a lot of and customization of these any objects. So the customization is playing a vital role. Maybe here, maybe some of the luxury companies which I mentioned here, but you have a lot of applications where the automobile people are looking at for the 3D printing application, making in terms of dies or tools or fixers. So of course, you have a lot of scope to work on the molds, the metal castings. So you can make sand, core sand. Further, you can make the metal and wax, and then ceramic mold and metal. So in this way, you can have a lot of molds to make through this 3D printing technology. And of course, another advantage is the part consolidation. So 100 parts are consolidated into a single part. So that is the advantage, where 95% weight reduction and 20% reduction in the production cost and 75% of the non-recurring cost. So this is what where otherwise you cannot achieve a conventional way. So conventional design mindset. So you come out with your mindset like a 3D printing mindset, and then you design accordingly. You consolidate, or you take the inspiration of the design through nature or whatnot. So you can do wonderful things in 3D printing, but until unless you have a design mindset, you remember. So then you have we can see nowadays a lot of articles saying that we can print the lenses. Yes, so people are printing the lenses. So you know the advantage of printing the lenses through 3D printing. So it doesn't require any polishing. So polishing is a major challenge for the traditional lens makers. So definitely you can exploit such kind of advantage here. And of course, as I mentioned, personalization, customization, and of course you can customize your as for your pressure points. So you can customize, you can design your customized shoe sole, and further you can print it. And it can be a kind of the fashion industry where you can print these customized dresses. And of course in the art, so you can have a lot of ceramic printing is happening, which you can print them. So how beautifully you can imitate the nature, or a kind of see the realism of these 3D printed parts. And of course, food printing is another area where you can print the chocolates, you can print the sugar candies, you can print even a shoes. So you have a lot of scope to work on the food printing, but still it is at the initial stage. But we need to explore a lot of things in the food printing also. So let me have some kind of a futuristic application for 3D printing. So Of course, bioprinting or the organ printing is going to be the emerging trend in case of medical application of the 3D printing. So that is going to be, so then earlier speaker has already clarified. So as per his thought, it may be 10 years to replace the complex organs. We doesn't look for a donor to donate. So they may take your own cells, your living cells, and they will add the nutritions, and they will put it in an incubator, and they will test it in a bioreactor, and then they will inject into the your own body, which is cultivated, taken from your own cells, living cells or stem cells. So that is the beauty, or that is going to be the futuristic application of the 3D printing in case of medical applications. And of course, you have a two extreme sizes of the products. You have a micro-sized micro SLA or 2-photon polymerization process. Is you have one side is the smallest feature we can make, and you have other side, you have a huge scope in a construction industry where you can print the houses, or we can print the buildings or apartments. So that is coming in a big way. So you have a two extreme sizes of your products. So right from the micro scale to the big buildings like this. So you have wonderful products, and of course you have some kind of a futuristic application where robotics, you can integrate the robotics into the 3D printing scenario. So where Nanyang University, they are developing these kind of structures built from the robots, which is controlled with the the advantage of a robotics, and you have more degrees of freedom rather than a conventional 3D printer. As of now, you have only 3-dimensional 3-axis freedom, or some process like DED, you may have 4-axis or 5-axis freedom, but not more than that. But if you are using a robotic arm, you have more degrees of freedom, right? And of course, people are able to integrate your unmanned aerial vehicles, or your what you call your unmanned aerial vehicles. So you can correlate, you can swim it, you can fly it. So means basically you are integrating your kind of these kind of two technologies you are integrating, like unmanned aerial vehicle and the 3D printing. So you can create wonders. So then let me come to my last part of the presentation. So that is how it is going to helpful for the COVID-19 cases. And of course, as we know that these designs are nowadays, as I already mentioned, you have a lot of repositories or digital communities where you can download free of cost without designing by yourself. So then, of course, 3D printing will allow you to customize as for your size. So you can customize your safety goggles, or you can customize your the shields. So or kind of stuff like where you can do a lot of customization, and then it doesn't require any skill of the manufacturing. You required only the design or the blueprint. It may be already available through a 3D printing community or an online repository like Thingiverse, or it may be a GrabCAD, right? So otherwise you can customize as for your requirement. So then there will be there is no supply chain at all. So you need only 3D printer and the design. So you have a 3D printer at your home. So this is a quite fit for the lockdown period or the pandemic COVID-19. So where you cannot move from your home. So you have comfortably 3D printer at your home, and design anyway through a web you can download. So then you can print it comfortably from your bedroom. So no supply chain management, or no supply chains which it otherwise. So how do you make this? Definitely it's going to be the injection molded die. So injection molding die. So then who is going to design the die, and who is going to fabricate? And it may take minimum 1 month to design and fabricate the die. But here it's only matter of hours to print these kind of customized designs. So of course it will be either a stopgap mask. And even from the France, this is one of the France hospitals. So again, I'm talking about the supply chain. You can install these printers at the hospital premises, no contamination, no supply chain. So then that is a wonderful idea, and these will be shared through online to the hospital people, these designs, and people are doing in that way. And of course in India also there will be people who is working at 3D printing community. So to design an indigenous stopgap masks, or you have other ventilator devices, so you have a wonderful opportunity. Otherwise, we can put 3D printing is COVID hero. So we can put it in that way. 3D printing is a COVID hero. So it will take a lot of challenges. So of course, the life-saving kind of thing. So normally, as we know that the ventilators is badly needed, but of course, people are looking for the alternatives for the ventilators, maybe towards a PEEP valves, or maybe it can be a respirators or any other stuff where we are going to totally replace the ventilator, but not all the patients, but the people who badly need it, definitely there will be a ventilator should be supplied. But the people, not all the people, as for the survey, 5 to 10% maybe people requires the ventilators, but people who doesn't require ventilators, but of course they may be at a kind of criticality in the virus. So definitely you can, 3D printing will help you out to print, to customize a kind of devices or PEEP masks. So this is from Materialize community, so where they will be sharing these designs, and then you can print them, and you can connect through HEPA filters, and basically this is the oxygen supply. So then you can have this oxygen supply, and through this filters, and finally it will come to your the patient mouth. So this is what, where you can 3D print these kind of stuff. So where the COVID situations, so it is very crucial. And of course the respirators, so this is from the HP, and Reddington in India, they have a collaboration, and in India also the HP has extended the hands, so you can download, go visit and this HP website, you can customize the respirators, so you can do a lot of stuff. This is 3D printed through HP 3D multi-jet fusion technology. And of course you have a respiratory mask kind of valves, so where the oxygen will come through this kind of a battery operated kind of a blower, and the oxygen will come, and what the business of 3D printing, so it will print this kind of a mass or valves, so for these kind of applications. And of course the people are reverse engineering these kind of oxygen valves. Why? Because these oxygen valves is badly needed, say 200 to 300 per day. So that is the kind of the requirement. So then there won't be time to ask the supplier, can you supply 200 or 300 per day? And these we have to you doesn't reuse these valves. So we need to have one patient, one valve. So that is the challenge. So then people are even reverse engineering or re-engineering it. So, and of course we have a lot of tests are pending in India also, like where we need to have some kind of rapid test. For that we have a nasal swabs to 3D print in a mass production, maybe in a single go, maybe 200, 300 in a single build, maybe matter of 10 hours, or maybe 20 hours, you could be able to make a 300 or 400 nasal swabs like this way. And then of course the designs will be shared to the hospital community, and they can even have a 3D printers in the hospitals, they can print, and you can use it for the diagnostic purpose. And of course the Materialize, they have come out with, and nowadays you can find a lot of these kind of thing in Amazon also, so which you can basically you can 3D print once you have a designs. So it may be even hardly, it may be costing you maybe less than what the Amazon people are selling you. Why? Because your 3D printing spool may not be much costly, PLA or ABS if you use. Then for this case, you are not going to use it for the frontline applications of the hospital staff. So very well you can use it PLA or ABS. So then we have such kind of applications. And of course you have a quarantine booths also, so which you can 3D printed quarantine booths, or 3D printed like this kind of a pandemic, where people are printing these kind of a booths with electric supply and water supply. So then we can use the 3D printing construction or some disaster management like this. And of course the unmanned aerial vehicles, you can again payload, like in the aerospace, and similar principle is works here, like how to minimize your payload. And of course your 3D printed parts, so again you can vary the fill densities, you can mimic lattice structures, you can bionic designs, so we can almost reduce the weight of the unmanned vehicle, so either towards battery assembly or electronic assembly. So we can reduce a lot of you can scoop out these material and reduce a lot of weight reduction. And of course ventilator, people are looking for the substitute or the alternative for the ventilators. And one more idea is how normally the ventilator will be supplied 1-to-1, one ventilator, one patient. But how do you scale a single ventilator can accommodate minimum of 2 and a maximum of 4 COVID patients who requires ventilators? So that is the idea where you can find a lot of designs available. Like this is a Whisper. There is a company from Prisma Health. So where they have designed this, and don't use a conventional PLA or domestic kind of a material. So we need to be FDA approved. Why? Because you check repeatedly. I am telling what is your application, whether it is going for the frontline people or simply for your a common public. So where the product is going. So what is the application of it? So definitely it is the frontline. We have to take approvals from FDA, or the appropriate clearances should be taken from the appropriate authorities to use this for this kind of a critical ventilator, either splitter or any composite, any component. So this is one other case study. So where I don't have much of the time to discuss, let me quickly conclude my session. The people are looking to convert the manual into an automated ventilators through 3D printing. And of course, we can beautifully print a kind of infection or a kind of COVID infected patient, how these lungs are infected. So which we can even see how beautifully with the vascular structures also it got printed, and see how much infection that the COVID patient is having. So in contrast with a MRI or a CT scans, so you beautifully you can print them in a beautiful way, right? And what could be the future? So let me conclude with these 2 slides. So what could be the future? So of course the future is going to be one dimension ahead, maybe 4D printing. So what do you mean by a 4D printing? So 4D printing is all about basically you may have a 3D printed structures, and 3D printed structures normally it's a static structures, but you are going to make a dynamic structures through 4D printing. How it is possible? So definitely the material is the key. So you may be going to use a shape memory alloys or a smart materials, and further you need to have some kind of a stimuli to stimulate or to getting deformed the shape, the static structure into a dynamic structure. So as for the situation or the environment, it's going to adapt as for the environmental conditions. So it has to adapt. So if it is an hot valve, so if somebody is getting some heart stroke, and the smart material or the 4D printed valve which you implanted into the heart of a patient who is having a massive heart stroke, won't allow the blood to block. So it may allow to flow the blood. So that is the life-saving application. Definitely it's going to, very soon we can see these kind of 4D printed components. So of course it's going to be a kind of a micro nano sized 3D printing parts also, which we are going to experience, and it can be a 3D printed batteries, or it's going to be a voxel based printing. It's no more, it's going to be the layer based. So this is only the prediction. So definitely why it should be a 2-dimensional 2.5D layers should be stacked together. Why can't be a voxel? And these voxels can be in a terabyte size, or in a mega giga or a tera per second. Can you print them in that speed? So that is going to be the future. So let me conclude. Whatever we are seeing the applications so far, it's just a tip on the iceberg. So you have a lot of applications to come. So let me conclude this session here. So I might have exceeded the time also. Sorry for that. So I am handing over to the Narayan Reddy, and you can ask the questions. Yes.
Thank you,
Thank
sir.
you, Dr. Ravi Kumar sir, giving a wonderful lectures.
Thank you.
Yes, if anyone is
Hello.
having questions.
Yes.
Hello.
You sir, for
Sir,
2 minutes.
One by one.
hello.
Please. Yes.
Hello.
Yes.
Yes,
You
sir.
are audible.
Good afternoon, sir. I'm Shreyas. I'm calling from Amravati, Government College of Engineering, Amravati. Sir, I wanted to ask that if by chance I have any, any chance of using or like experimenting at NIT Warangal by any
Um,
means,
yeah, sure. You see,
using the
actually,
lab.
yes, yes. Actually, because of lockdown right now,
No, no, no.
we
Afterwards,
yes,
like
definitely.
anytime.
Definitely, we are in the process to work out. Why? Because recently only we have installed this just before the lockdown period. So we are working out. You be in touch with me, then I will send you the quotation or like kind what can be the charges. Yeah, definitely
Yes.
we are ready to help you out. Correct. Yes.
Oh, okay, sir.
Sure.
Okay, sir. Thank you.
Yes. Hello.
Hello, sir.
Yes. Yeah, Rajesh.
Okay. Uh, Actually, my doubt was like the products will be produced in a mass, like it's for mass production.
Mass production. No, can you
Okay.
elaborate? Like, yeah, yeah.
Let us assume that 10 products are produced.
10 is not mass actually. Okay, 10 products.
Okay.
You talk
Leave that
about
mass
10.
production. We'll talk about the 10 products. Will
Fine.
all the 10 products be similar?
That depends on your design. Like similar means, so that's what actually we have to think in out of the box. Like so, no, still I am not getting your question. Like what
Okay.
all the 10
My
designs.
actual question is like if the 10 products are not similar, then each product will have a defect. So how to overcome those defects in 3D printing? Can we get a defectless product in a 3D printing? Because we are talking about something aerospace components,
Yeah,
automobile
yeah.
components.
Yeah, I
So it
got your
should be
question.
defect
I
free.
got your question. Yeah,
Yeah.
repeatability. You are
Yeah.
trying to ask the repeatability. If you produce one part and you test it, and you produce 2, 3, 4, 5, 10, and what
Ye-
about the quality of the first part and 10th part?
Yes,
Wonderful,
sir.
wonderful, wonderful question. I appreciate for your
Thank
question.
you.
Yes. So the repeatability is very bad in 3D printing, especially metal 3D printing. So as I already said, there are no such standards, there are no such benchmarks.
Uh-huh.
The setting up a standard is also challenging. Why? Because so each product is a customized and each product is a customized one. Then how can you generalize these kind of standards? So each time you are changing your design and each time
Mm.
you are customizing it. So definitely it is a challenging. As of now, it is
Mm-hmm.
not producing a repeatable 100%. Definitely, again, it depends on. That's what I'm telling you. Have a huge scope to work on these simulation based studies.
Okay.
Say you can work. You have a large huge scope in this, especially metal 3D printing. Why? Because this very costly material and costly machines. So if the repeatability is not good, so the idea here is how they are going to overcome this kind of a challenge is definitely as of now only post processing.
Yes, sir.
But if you could have a kind of in situ kind of monitoring and in situ kind of inspection and in situ kind of correction through process parameters, that's what
Okay.
industry 4.0, that's what your smart manufacturing is all about. So
Yes.
definitely, so once it industry 4.0 matures, your artificial intelligence or a kind of sensors or a kind of feedback systems, so definitely it's that is only the solution. And anyway, Professor Krishnanand is going to talk much on the standards. Very few standards, and that too, it is a customer based standards or it is a
Okay.
user based standard. Say for example, GE. So GE has some kind of a tie up or the collaboration with as you already mentioned, aerospace component. Yes, wonderful. So GE has collaboration with ASTM and ASM. So they
Okay.
are working in that way and they are coming out the standards. So that is the situation now. So definitely repeatability is a challenging one. Yes, I appreciate your question and I hope I have answered your question also.
Yes, sir.
Right.
Thank you, sir.
Sir, one question from chat box.
Mhm.
Sir, are all the AIM processes have capability to produce heterogeneous parts?
Heterogeneous?
Heterogeneous parts.
Heterogeneous means what? Like functionally graded material?
It's not same
Functionally,
composition. Different.
functionally graded materials. He is trying to put. Who asked that question? Like, can you elaborate?
Abdul Rashid sir, he asked the question. Can it
Is
be
it a
possible?
right? So maybe his question may be FGM, maybe functionally graded material. If I am correct. Yes.
Yes, sir. Yes, sir.
Very good. Very good.
Yes,
Very
sir.
good.
FGM.
Yeah, Abdullah. Very good. I appreciate for your question. FGM is not possible with all the 3D printing processes. DED is one for the metal. You can make FGM through DED process. DED process is only support metal functionally graded materials. I hope I have answered your question, but not rest of the 6 processes. It's not possible to produce. I am talking about FGMs in metal material. Yes, I hope I have answered your question.
Sir, PolyJet 3D printing, it has the capability to
That's
develop
what.
a part with different metal. PolyJet also has the capability.
No. It's not metal. Let me correct you. The PolyJet is not for metal. It is for the polymer epoxy resin. So it will come under the jetting technology, and it can produce multiple grade material, but it is not functionally graded material. You try to distinguish between FGM and multiple material. Here is like, say, whatever you're saying, the polyjet can capable of printing in, say, I have a flexible in somewhere, and I have rigid in somewhere, and I have opaque in somewhere in my product. I can print it in a single go. Some portion where I have a flexible region, and somewhere I have a rigid region. So that is for polymer. That is called multiple material with the varying properties or the flex. Hello.
Okay, sir.
Hello.
Okay, sir.
Yes.
Yes, sir. I am
I
listening.
hope I answered the question. Yes. I
Okay, sir.
think
Thank you, sir.
I think we are running short of the time. I think we can. You can very well. You can. I will be available with you. Like, you can ask further also any questions if you are having. So Narayan Reddy, can you run the?
Also,
Yes,
so
we
one
are
more,
crossing.
so one more question. Just one question is asking.
Right.
Generally, SLA is for polymer based material. Why there is a huge research gap for SLA on ceramic and metal? SLA on ceramic and metal is asking, sir. Is it possible?
Yeah, it's possible. Who is asking that question?
Arirajan.
Yeah, wonderful.
Sir, hello.
Wonderful question.
Yes, sir.
Yes.
No, sir.
Not SLA exactly, but it is possible. Ceramics. That we'll talk. Actually, I have a session on 3D
Yes, sir.
printing processes 1. We will discuss. It is very much possible, but lot of challenges. We need to have a post processing to do.
Okay.
But it's very much possible. We can discuss that. Yeah.
Okay, sir. Okay, sir.
Narayan,
Thank you.
Run the poll. We can run the poll question, that Google form.
Okay.